Good morning, everyone. Today is March 9th, 2019, and this is the John Chappell Natural Philosophy Society Science Chat. And we welcome you to join us at naturalphilosophy.org, where you can join our membership and stay informed about what's happening. We are on social media, on Facebook, and also on YouTube, where you will find recordings of these science chats. And we would invite you to help us out by joining Basecamp, which is hq.naturalphilosophy.org. And our rules of conduct here is that we would like to treat all participants with respect and politeness. And please, no personal attacks. We should be discussing things purely on a scientific basis. And please make sure that your microphone is muted and your video is off if you're not speaking. We do have our upcoming conference, June 26th, 29th, at the University of Washington in Seattle, which will be featuring Dr. Gerald Pollack. So today we have our special speaker, Eugene Ellis, and his topic is going to be the Ionic growing sun, earth, and moon. So this is based on a talk that Gene gave during one of our last year's conference, I believe. So I just advertised our current conference. So this would be a sample of how you can present your material during the conference and have it recorded. And then later you can show that to other people and discuss it. So we haven't done this before, but the way I would like to do this is that I'm going to play Gene's video that was recorded from the conference. And if you have a question or you want some clarification, please go ahead and put something in the chat. I'll be monitoring the chat, and I will pause the video and we'll go ahead and just do whatever questions that you have for Gene at that time. So rather than just letting the whole video play uninterrupted and then save the questions to the end, let's try and make this a little more interactive. And as questions come up in your mind, please put them in the chat, and then we can immediately discuss them before a whole lot of time has passed in the presentation. All right. So Gene, did you want to make any kind of introduction before we play the video?
I don't think so. I think just start with it and see where it goes.
All right. I know if Harry was here, he would probably want a little introduction of what your background is and why you got interested in this.
Well, my background is not really in science. I'm an engineer. I've worked for the government for 20 years, and I was in business with my brother for another 20 years in construction work. And when I retired at age 60, I resumed interest in this growing earth. Mostly, I really got involved around 29 or 2010, and pursued it from there. And actually, I think it was Neil Adams' video that prompted me to review it in greater detail.
Yeah, I've seen Neil Adams. He has some very fantastic animations showing like the spreading of the continents as the Earth increased in size.
Yes.
So is your motivation to try explain the mechanism behind that increase then? Because Neil Adams he has some ideas, but
his idea is pair, whatever he calls it.
Pair production, right?
Pardon?
I think his idea is pair production, that somehow...
and that is viable, but I see it as requiring high energy levels. And those energy levels are not here today. They were in the past at the beginning, and I just don't see where it's feasible today, except in a laboratory.
Well, why would you not think that those energy levels are available? Because the core of the Earth is like hotter than the center of the sun, right?
They're available, but not here on Earth.
No, here in the center of the core of the Earth, it's well known that the molten core is extremely hot, like surface of the sun hot.
Yes, it's extremely hot, but that doesn't mean you have the high energy levels in the gamut of range.
Do you think you need energy in the gamma range?
Yes, for pair production.
For pair production. Okay. Well, I think that gives us a background of what you'll be presenting here. So I'm going to get the video started. And so for people who are not familiar with use the chat, there's a button that's on the bottom that looks like a little text bubble. So I'm going to chat to everyone and say here, this is the chat. Please put your questions here. Or if you're really bold, you can just shout into your microphone and I will hear you. But I would prefer that you put your questions into the chat. All right. So let's get going. So this presentation is about 30 minutes, and we'll stop it after the questions and answers.
Good afternoon. I'm Eugene Ellis. I'm an old retired engineer from Slower, Lower Delaware. I got interested in Earth expansion after retiring, trying to fit in some of the missing pieces. Okay, I'll have you. You need to go to the next slide? You got it. Donald Rumsfeld once remarked, reports that say something hasn't happened are always interesting to me because, as we know, there are known knowns. There are things we know that we know. There are known unknowns. That is to say, there are things that we know that we know. No. There are things we now know that we don't know. But there are also unknown knowns. There are things we do not know, we do not know. Missing is unknown knowns. The things we don't know, the consensus says we do know. Consensus says matter is unchanging. Atoms cannot change size. Consensus says the ocean floor is subducting. Less dense matter is piercing more dense matter to recycle in the mantle of a constant radius Earth. In the universe, all matter that matters consists of elemental atoms. We can see most elements, but not their atoms. All elements are different from one another, as are their atoms. We think we know much about ionization, but we don't know when it begins or all that it does. We don't know what we don't know. In 1970, Charlotte Moore compiled and published MBS 34, Ionization Potentials and Ionization Limits Derived from the Optical Spectra. Table 1 of MBS 34 indicates normally normal matter is detectable and identified in the spectrum and lists the IP for each element. This is a copy of NBS 34. These are the first 30 elements from that publication. Ionization potentials are energy levels in electron volts when an element has the potential to join other elements. It's more or less a chemical definition. Much can be gleaned from this table of ionization potentials. First, the energy is contained within the element. Reading the chart from left to right is reading from present to the past, and from right to left is reading it from the past to the present. Notice the small incremental chain jumps between the IPs that suddenly become large jumps in the highlighted areas. This anomaly signifies something different is occurring. The first time an element ionizes, it becomes normal matter and its intrinsic energy begins to decay. Exceeding the highest IP for any element indicates such element is undetectable and exists as dark matter. Presently, all the elements have ionized, hence there is no remaining dark matter when considering all matter in the universe consists of elemental atoms. Additionally, these ionization potentials provide the data for finding an energy rate of decay by utilizing the atomic mass, the quantity percentages of the mixture, and an exponential W equation, y to the x equals 2. This method was discussed at the CNPS 2016 conference in College Park and can be found on the first 2 pages of the Ionic drilling Earth paper on my website.
Okay, so let's see. Let's pause right there. Now, one thing I want to make sure is that if you guys ask a question, whether I can actually see that or not, because when I go full screen here, I might not be able to see what's going on in the chat. So can someone put something in the chat, and I want to see whether I can actually see that, or raise your hand or something like that. Right now, I'm not really seeing anything. So do I have to stop the sharing in order to see those? Okay, so Mitch, you put in a test question, and I don't think I could actually see that while I was playing the video. How about someone raise their flag? There's a option for people to ask questions. I can see Mitch raised your flag. Now, if I'm sharing that video, will I still see that flag? Let's try that. Mitch raised your flag. Okay, so I can see your flag. So if you have a question during the middle of the presentation, then go ahead and raise your flag. And then I can see that. But I want to stop here, Gene, to go over this, chart. So this seems to be pretty important, but I'm not quite sure I understand, Gene. What do these numbers mean here? Like in lithium, it says 5.3, and then it says 75, and then it says 122. What do those numbers actually mean?
Well, all the units are in the electron volts. And Charlotte Moore explains that in the first few pages of the NBS 34 that was published. They have another system, but everything was converted to electron volts.
Well, does this mean that that's the amount of electron volts required to ionize off the first electron, and then 75 is the amount required to ionize the second electron, and then 122 is the amount required to ionize off the last electron, so that you have no electrons left? Is that what that means?
We're down in Roman number 1 phase right now on the chart, and that's the ground state. So to go upwards, as you would need a second state also. But what we're discussing, what I'm trying to show here mostly, is reading the chart from right to left, from past to present. And that doesn't
make any sense to me, because there's no concept of time in an ionization potential. So why would you say from past to present?
Well, because I put a time on it by using the rate of decay. And that rate of decay is all the elements lose 1 electron volt every 1.6 million years. That's the rate for Earth.
Well, why would you call that a decay? I mean, typically a decay is when a element transmutes into another element by falling apart, basically, through some sort of radiation. Well, you're talking about decay in a different sense. You're saying that there's going to be a change in this whole chart over 1.6 million years?
Each element individually, every 1.6 million years, would lose 1 electron volt. When it starts at the high end for, say, calcium. Calcium was the first element to ionize, and at 5469 electron volts. When you multiply that by 1.6, you end up the time that it ionized for the first time, and that would be like 8,800 million years ago. That was the first element to ionize. The last element to ionize was hydrogen.
What do you mean by ionize? See, I'm confused, because when we talk about ionization, that's usually like if I take a gas and I shoot electricity through it, you can get the electrons to ionize away from the atom, and then they emit electromagnetic spectrum, and but they do fall back. They fall back in the ground state, and that's a very temporary kind of action. So what kind of ionization are you talking about here? How can calcium ionize? It wouldn't be a permanent state.
These are the ionization potentials. That's when they are capable of joining other elements by the chemical definition. But it also tells you other things. If you go beyond the highest level, you're moving, the element still is there, but you can't detect it. So I would call that dark matter.
Why would you think you wouldn't be detected? I mean, you can take lithium, you can remove all 3 electrons, and that would leave the positive core, and certainly that is detectable.
Lithium, if you go past 122 electron volts, it's not detectable.
That it would be perfectly detectable if you put fully ionized lithium atom through a cloud chamber. You would most certainly be able to see it.
Franklin Hugh, this is Bill Howell. Can I make a comment?
Yeah, sure. Go ahead.
Yeah, I believe, if I remember correctly, that Randall Mills, with his theory of fractional quantum levels for electrons, which is interesting in terms of Bill Lucas following work of Ted Berger and others and his own on the same theme, that he has a similar explanation for dark matter, in that fractional quantum levels of hydrogen would not be detectable either. That's slightly different than what's, the ionization issue, but it still may be relevant to this conversation. Thanks.
Okay, well, I think it's trivially simple to prove that if you ionize an atom that you can still see it, and that would be the case of hydrogen. So if you ionize hydrogen, you get a proton, and protons are clearly visible. It's not, that's 100% ionized hydrogen atom, and you can clearly see it. It didn't turn into something invisible, and I'm positive that if you were to do the same thing with helium, those are called alpha particles. We clearly are able to see those. So, Gene, I wonder, what do you think of that? It's like, I'm based on my current knowledge of physics, these things fully ionized are still completely visible.
But I think that Eugene Ellis and Randall Mills are making a statement that doesn't fit into that normal conventional assumptions about the ionizations.
Well,
and
that's an assumption. That's the empirically observed fact.
And Randall Mills and Bill Lucas do pick out astronomical spectra. They pick out lines that they attribute to fractional quantum levels. And again, this is somewhat different than your normal ionization. But they also, Randall Mills is very clear that in a lot of cases, it's too close to some well-known spectral lines, and that it would be very difficult to make that distinction. And in other cases, Randall Mills was looking for lines that should have been there theoretically, but he still hasn't seen or found. And by the way, he did have to use some very, very special spectrographic techniques or sources from special techniques to extract that information that normally a scientist would not get.
Well, Bill normally talks about the spectra, as in his models can predict the spectral lines that nobody else can. Although I don't believe that is this data that we're looking at. There's two different things that you can look at, and then this table is showing ionization energy, which is the amount of energy required to remove an electron from an atom, versus the spectra, which is the actual frequencies which come off of an atom when it's being ionized, and those come off in wavelengths rather than electron volts. So those are two different things.
I agree.
And I wanted to ask Ken. Okay, Gene. I would contend that once you ionize all these atoms, they're still perfectly visible. They become highly positively charged, and in fact would actually be extremely visible because of that.
I didn't get your question.
Well, Gene, I'm just contradicting your claim that if you were to ionize all the electrons off an atom, that it would become dark matter. I'm just saying I don't believe that is the case.
I'm not speaking about the electrons. The electrons is part of the standard model configuration. If you want to look at it from a standard model viewpoint, where you have these electrons encircling the nucleus, that's one way of looking at it. If you look at it from the electromagnetic area, they don't have those electrons zipping around the nucleus. And it's just these pulsations that identify the element.
But I still don't understand your contention that this somehow describes dark matter.
Well, it's not detectable in the spectrum, therefore it still exists. You can't say that that element came into being at that certain electron volt, the highest IP listed on the table. You can't say that's when that element began, because it existed before then.
Hydrogen doesn't describe that. All this is describing is the amount of electron volts required to remove an electron from an atom by convention, by mainstream convention.
There are a lot of people, not just Randall Mills, and perhaps Bill Lucas, but I can't remember. But I'm thinking especially of the Ben Davidson of Suspicious Observers, has been receiving an enormous amount of material about the failures of all attempts with extraordinarily expensive experiments to detect dark matter, and yet we find out that they have not been able to detect dust and plasmas. And they're just starting to get a little bit better at understanding plasmas in some of the conventional science, but a lot of people have been decades harping on this issue. What is dark matter? And Eugene Ellis is perhaps suggesting, and very justifiably, if some ionizations don't show up well, or those elements don't show at all in normal spectroscopy, it is dark matter. In fact, the groundswell is that dark matter is just ordinary matter that we can't see, which makes perfect sense to me. What do you do for a planet or I forget which star it is, the kind of like the dead stars that don't radiate? How do you pick these things up? That might have been a bad example, but the dust and plasmas are great examples where they're just starting to get going on that.
Well, that's an interesting concept, but I don't think we determine the presence of matter. Well, let's see here. Maybe we do, but do we determine the presence of matter by its spectral return? So you're saying that if I take oxygen and I completely ionize it, so it's just like a ball of protons, then and you keep it that way, then that's not going to emit any light through any kind of action, right? So,
well, I think the point here is not because I think they do pick up oxygen and some other things, but the question is they're definitely not picking up an awful lot, and they've been steadfast in their refusal or the camouflage of this omission, and it's huge. It could be potentially huge. Who knows? 95% of all matter in the universe is dark. Maybe it's all dust. Maybe it's all plasmas of a certain type they haven't been picking up. But the main thing is not what the answer is. The main thing is, the question is, wait a minute, people are pointing out we cannot pick up many forms of matter in astronomy. We're missing these pictures. And we're getting more and more of this material confirming that we don't necessarily need, why would you assume a mythical beast when you already know you're not picking up an awful lot? To me, that's, I like really crazy, creative, visionary thinking and all that, but I also like people to be honest about that. And quite frankly, I do not think that mainstream science is honest about this issue at all. And therefore, just keep our minds open, that's all.
Eugene seems to have some idea here for an alternate explanation for dark matter, which is what I'm trying to explore here. But he's also pointed out the section here that's highlighted in blue, where we can see some pretty significant jumps in these energy levels. So for like line 5, this energy level goes from relatively low 37 to relatively large 259, which is a pretty big jump. And these jumps appear typically at the end. So, Gene, what did you say was the significance of these jumps? What is significant about those?
The large jumps indicate that an anomaly, that something different is occurring than the rest of them. You go along with these small incremental jumps, about every 8, and then you go to a large jump. And so that's indicating that something different is occurring, and we'll pick that up on a later slide.
Okay. All right. Well, I think we've answered as much as we can. Did anyone else have any questions on this slide before we go on? No? Okay.
Find the data of finding an energy rate of decay by utilizing the atomic mass rating of the Ionic zone for this paper on my website. Decay rates of Earth, Moon, and Sun. There are 8 elements that make up 98.8% of Earth's matter. The first 4 make up 93%, and the last 4 make up the difference. On Earth, 1 electron volt decays every 1.6 billion years. There are 6 elements that make up 99% of Moon's matter. The same elements that the Earth possesses, except for sulfur and nickel. Now, of course, different percentages of all. On the Moon, 1 electron volt decays every 2.0348 million years. There are 5 elements that make up 99.57 of the Sun's matter. Helium and hydrogen make up 98.1% of that. On the Sun, 1 electron volt decays every 8.29 million years. If you multiply all the IPs on Charles Moore's chart by Earth's decay rate, it will give you the time of occurrence of those IPs. Calcium was the first element to ionize 8.8 billion years ago, and hydrogen was the last around 22 billion years ago. When you plot the IPs of the 8 Earth elements using redwood anomalies, you get this figure. This is over a 4.5 billion year period. Here, the anomaly identifies the origin of heat. Heating that was necessary to melt the 32.1% iron, almost a third of the Earth's matter, that gravitated to the core of a smaller Earth. The same 8 elements that started the Earth heated the Earth for the first 3 to 3.5 billion years. This changes everything we think we know older than 700 or 800 million years.
So, Gene, going back to that chart there, so I don't understand, where are you getting this data from?
I'm taking the 8 elements, the IPs of the 8 elements.
What's the IP?
The ionization potentials listed in Charlotte Moore's chart of the 8 elements that make up the Earth. And then I've taken at each ionization potential, I've multiplied it by 1.6. And that gives you the time of those ionizations. Now, when the anomaly, the time for the anomaly is what I put in red, and the other time would be the growing time is in black on that chart. So it's the same chart that a time factor has been included, and these are the times that those elements are heating or growing.
So what's the significance of 1.6 million years? How did you arrive at that?
That is better described in the Ionic growing Earth paper. And yeah, well, we can go through some of it. Let's see.
I'm just kind of wondering where this chart is coming from. So for example, for oxygen, you have this going up to like, I don't know, was it 1,400 million years or something, and then it ends?
Right. That's the highest limit of oxygen.
That means it's not growing or shrinking or anything? It's not heating or cooling?
Say that again. I didn't hear.
Does that mean that you don't think that oxygen is heating or cooling currently? It's remaining the same size?
At 1900? At 1400?
Yeah, because your chart stops there. What does the stopping signify?
I didn't hear that too well.
Like for oxygen, the line is less than 1500. It stops. So
yes,
what is
right.
the stop?
Beyond that's the ionization limit of the highest number found on Charlotte Moore's chart. If you take the highest number and multiply it by 1.6, you come up with 1,400 million years ago. That's when oxygen was capable of joining other elements. And it did. When 2 hydrogens joined oxygen, it became water 1,400 million years ago. The first water on Earth happened when oxygen ionized for the first time.
That doesn't make any sense to me. I can join oxygen to hydrogen or carbon or any other element today, right?
Today you can, yes, because we're at a different energy levels today. We're down in the ground state. 1,500 million years ago, you couldn't join oxygen to anything. It wasn't capable of joining until it ionized for the first time.
Well, that still doesn't make any sense to me. Now, I could understand that if you were in a high energy environment with oxygen and everything was ionized, then I can understand that you would not be able to make chemical elements at that point. There's just simply too much energy.
You're not making any chemical elements. Chemical elements existed from the beginning.
Yes, but I still don't understand what you're trying to say about ionization. I can understand what I understand about chemistry is that you have to have the right. You can't have the electrons ionized away from the atom in order to form a chemical element. So, like I said, if you had an oxygen atom and it was totally ionized, then you would not be able to form water. You would have to reduce the amount of energy to the oxygen so that the electrons could come back to the oxygen atom, and then they could bind together with hydrogen to form water. That's what I understand. But what you seem to be saying is something
different. Yeah,
I'm saying different. I'm trying to understand what that is.
I'm saying that once you exceed the highest limit of any element, that element existed as dark matter. It couldn't join with other elements. It couldn't decay. It couldn't do anything. It was just existed. You could probably detect it gravitationally, but other than that, you couldn't detect it.
Well, once again, I mean, we can detect fully ionized hydrogen atoms as protons.
Well, you're getting into the I don't know what we call it, into a different physics of all this. And really, I haven't used in the whole calculations, I haven't used any of the quantum mechanics or what is thought of as modern physics.
Well, that could be a problem because people are familiar with that. And what I'm talking about is not even that much in the way of quantum physics. This is just, I'm quite familiar with atomic physics. So I know what the terms ionization means. So if I take a hydrogen atom and I ionize it, which means you remove the electron, the remnant is the fully ionized hydrogen atom, which is a proton. That proton is completely detectable. We most certainly see that in our...
When is all this occurring? What time frame?
I can cause it to happen anytime. See, this is the thing that I'm not understanding about your time frame thing, because you can take any atom on the Earth, you can ionize all the electrons off of it, and then they'll come back. You can do that at any time. Do you not accept that concept?
No, I don't. I'm into a different concept.
But that happens. This is what we normally consider ionization. You know, even large atoms, even an oxygen atom. You can.
I don't think we know everything
from an oxygen atom, and then they will come back, and you can do that anytime.
Well, in your experiments of doing that, that's fine. I'm saying that it's not necessary. I'm saying that. Well, wait a minute. I will agree with hydrogen that hydrogen can join any element in the dark state. So oxygen 1,400 million years ago, dark hydrogen could join it, and that's the exception. And maybe helium will be included with that also. But hydrogen, even as dark matter, can join any other element if the other element has ionized and is ready to accept hydrogen.
Why would that be an exception?
It is. Because hydrogen and possibly helium are the two exceptions on the chart.
Well, I still don't understand why, but I'm just getting back to this chart, though. I'm still struggling to understand what is the significance of the length of these lines. So
the length of the line, if you look at it, you'll see more red than black, and that signifies that heating, which is another physics shortcoming, is on an equal par with growing. Growing mass and heating mass are on an equal footing. You see more heating than you do growing. And this is all coming from the intrinsic energy of each element. Energy is converted to heat, and energy is converted to growing, additional mass.
Okay, but I'm still struggling. I mean, is it just me, or do other people have a hard time trying to understand what this graph is showing us? You know, I'm just not really sure. I mean, I could. Now, on your time scale, what does does that mean? Does that mean 0 means today and 500 is 500 million years ago? Or is it the opposite, that 0 is like the beginning of time and everything to the right, the current time is to the right somewhere?
0 would be today.
0 would be today.
And
okay.
That would be, as far as the ionization potential scale, that would be the ground state.
So you're saying all of these elements have reached the ground state. And
yes.
And so currently it looks like most of these elements are black. Yeah, it looks like all the elements right now are black. And so you're saying all these elements are growing right now.
That's true. All 8 elements are growing.
But so you're saying that, say around 3,500 million years ago, we have aluminum, and aluminum was unreactive until about that time, and then it was in a growing phase, and then it was in a heating phase.
Yeah. That's correct. It started, aluminum when it first ionized at, I can't even read my numbers here,
3675.
Yeah, at 3675 million years ago, it ionized for the first time, and then grew for roughly 200 million years. Then it reverted back to heating down to around 700 million years ago, and it reverted back to growing again until 191 million years ago, and then it reverted to heating again, and at 45 million years ago, it went back to growing.
Okay, so and somehow this is based upon that ionization chart that you showed.
That's correct.
And the 1.6 million years.
Right.
Okay, well, I think we're just going to have to stick with that as our understanding. Maybe it'll become clearer as we go on. Does anyone else have any questions about this graph?
This is Bill Lucas. I have a comment. The ionization potential of atoms was remeasured by NIST since the time in 1970 for the data you're using, and they now measure it to 8 significant figures instead of 6. And so we have a little more accurate measurement of that. And that's on the NIST website. If you go and get it for all the elements, just like you show in your chart. The interpretation as to what is going on in terms of atoms is difficult to make, but from the work that I have done, I can give some interpretation as to what may be going on here if you would like to hear that. But
well, I would be in what you think of Gene's theory here.
Some of these effects he's talking about apparently do exist, but the current theories of the atom cannot explain it. So it's not paid too much attention to. And people like myself who are doing work on the new theory of the atom, where we have the electron as a soliton, an electromagnetic field in the shape of a toroidal ring. What happens here is the electron does not orbit the nucleus, but it exists in shells about the nucleus, and those shells can vibrate. The vibrational energy is equal to the mass of that element. And the vibration is like dipole, quadrupole, octupole vibrations. They give rise to the cosmic background radiation. So they're slowly deteriorating in energy, and that changes the mass, and that changes the ionization potential to pull that electron out of that shell. So, so what we do see some things from a perspective like that, and but I don't think Gene has a complete model of the atom and of the role of the electron and that sort of thing built into what he's trying to say. So he's trying to do it more like an engineer, which is looking at the data and trying to see what I can say from the data itself, because that's the only thing that's real, because our models are not necessarily real. They may be imaginary, if you know what I mean. And so I think Gene is trying to say something about that. But in the work that I've done in electrodynamics, the force of gravity is entirely electromagnetic, based on the vibrations of these electrons in the shells about the nucleus. And we come up with a new theory of gravity, which has two terms. One term is the old Newtonian universal law of gravitation and Einstein's general relativity.
I can't get too much into that. What do you think?
And the second term explains all dark matter. So we don't have any dark matter in that.
So what do you think of this idea that Gene is putting forth, that we have? Because I'm not quite sure I understand what he means by ionization here, but that at some point in the Earth's history, that all the elements are non-reactive until a certain period of time, and that somehow that has to do with heating or growing. This is Gene's main thing that he's trying to put forth here. So plausible, not plausible? What do you think?
Well, what I'm trying to say is different models of the atom could support some of these ideas he's giving, and but the time frame on those models might be different from the millions of years. If you look at the age of the Earth and you take into account what are called radio halos, the age of the Earth drops from billions of years down to thousands of years. And so it depends. There's a certain amount of political correctness and exclusion of data in our postmodern philosophy of science, in which we have a separate silo for each field. And if the chemists discover that gravity is due to electrodynamic forces and not a separate theory, it's ignored by the physics community because that's a separate silo. And so different fields can make measurements, and their data is ignored. And it's troublesome.
Well, go on. Let's go on. So that's an interesting chart.
The origin of water occurred when oxygen ionized for the first time. That would be around 1,400 million years ago. The first ionization energy of oxygen was 871.38. And you multiply that by 1.6, you get around 1.4 million years ago. That was the first water. The origin of hydrocarbons is around 800 million years ago, and life depends on the hydrocarbons and oxygen. So the origin of life began around 800 million years ago. Without knowing when the basic elements can ionize and join other elements, life on a rocky planet swimming in water 3 billion years ago remains unchallenged and believable. Radiometric dating is not reliable for dating ancient rocks because it does not consider, I lost my place. There it is. Radiometric dating is not reliable for dating ancient rocks because it does not consider when the rocks were in a molten state. It should because no one can know the composition or the location of molten rocks a billion or 2 billion years earlier. These charts indicate that most of the growth on Earth, the Moon, and the Sun occurred within the last billion years. These are the calculation tables of the Earth, Moon, and Sun that basically deducts the heating phase to obtain the resulting growing mass. The X column, log 2 over log Y, is the mass doubling time for the years in the first column. The Earth is currently the Earth's current doubling rate is every 49.5 million years, while the Moon's rate is around 40.7 million years. The Sun is doubling its large mass every 16 million years, or 3 times faster than the Earth, while the smaller Moon is growing faster than the Earth. The left half of Table 5 for each, the Earth, the Moon, and the Sun, is essentially Table 4R. The right half results when the increasing radius follows the increasing mass by 100 years. The volume increases always lag the mass increases. Graphs of Table 5 for Earth and the Moon. Some interesting points are surmised when comparing the size of Earth from James Maxwell's book, Beyond Plate Tectonics, with the Ionic growing Earth data. When the radii are plotted, as in this chart, it is noted that the difference in size until 250 million years ago can generally be attributed to the growing continents, since the expansion tectonics model only closes the oceans. A halving of the radius, or gravity, is indicated as 50%, 175 million years ago for the Ionic growing Earth, and 240 million years ago for the expansion tectonics model. The differences between 250 million years ago and 600 million years ago are likely due to the size of the primordial radius, 1,700 kilometers versus 800 kilometers, and the time when exponential expansion effectively began. A second halving of the radius is indicated on the IGE curve, 25%, around 470 million years ago. A second halving is not possible with a 1,700 kilometer primordial radius. The 2011 Nobel Prize in Physics was awarded to Sol, Perlmutter, Brian Schmidt, and Adam Rees for, I quote, the discovery of an accelerated expansion of the universe through observations of distant supernovae. The yellow arrows indicate when accelerating expansion began on the Earth around 200 million years ago, and on the Moon around 250 million years ago. This graph indicates accelerating expansion started on the Sun around 110 million years ago, when the 71% hydrogen began to grow. During that 110 million year period, the Sun's radius doubled twice, once at 25%, around 105 million years ago, and again at 50% around 70 million years ago. The Sun's radius also doubled at 12.5%, 300 million years ago, and 6.25% around 370 million years ago, when the 27% helium was growing between 203 and 451 million years ago. I lost it again. Did I jump?
Yeah. So go back to.
The three minority elements are responsible for all growth between 112 and 203 million years ago, and prior to 450 million years ago. Doubling the mass 3 times will double the radius once, resulting from an 8-fold mass increase. Doubling the mass 6 times will double the radius twice, resulting from a 64-fold mass increase. Doubling the mass 9 times will double the radius a 3rd time, resulting from a 512-fold mass increase. This thing moves too fast for me. I lost it again. Doubling the mass 12 times will double the radius a 4th time, resulting from a 4,096-fold increase. The above graph indicates the Sun's radius doubled 4 times in less than 400 million years. The overall mass curves are exponential in nature, but the doubling rates between the points do not change, therefore are linear as shown. The oddity of the Sun's graph when compared to the Moon and Earth graphs is due to the break between the helium growing time and the hydrogen growing time, when there was very little expansion occurred. This break punctuates and changes the continuity of a curve that employs the identical exponential doubling technique for the Earth and the Moon. Similar punctuated expansions will occur on stars and other celestial bodies predominantly composed of hydrogen and helium. The mechanism for growing matter is the same mechanism that affects energy converting to mass in the equation E equals mc squared, except on a micro scale. Observing the photon is an example of pure energy at a higher level, transforming to additional mass at a lower level. A change in thinking about matter is long overdue. Everything in the observable universe changes with time. The problem of growing matter stems from a 13th century premise that the essence of matter is unchanging. Today, that assumption in the scientific world has become a certainty, meaning atoms cannot change in size or numbers. That certainty leads to confused thinking when considering the interchangeability of energy and matter. If one truly believes that atoms of matter cannot change size, then what is the energy converting to in Einstein's famous equation? Aging causes inherent elemental energy to decay, and decay involves a conversion process. Finding the rate of decay, which is dependent upon the elemental composition amounts present on a celestial body, allows knowing the time when the elements of such celestial body ionize, and when they are growing and when they are not. Growing old is a reason elemental atoms at certain times are growing larger, and ionization is an integral part of such mechanism. Increasing the amount of a substance does not increase its density, rather it increases the mass. Growing matter utilizes this intensive process. Hence, density remains nearly constant, only allowing for compression within a celestial body until the pressure is relieved and the volume expands. Volume increases always follow mass increases. Growing matter increases mass, not density. Gravity is not too much concerned about volume, but it is concerned about mass. Quantifying additional mass using the leap second data from Wikipedia. Between 1980 and the end of 2016, there were 18 leap seconds in a 36-year period, averaging 1 leap second every 2 years. Thus, 1 leap second per 2 years equals 0.5 over the number of seconds per year, which is 1.5844 exponent minus 8. Therefore, the amount of mass required to slow the rotation of Earth's present matter by 1/2 leap second with no change in angular momentum is the present Earth's mass, 5.98 exponent 24, times the above number, and you find 9.447 exponent 16 kilograms per year. This amount translates to the energy of around 3 billion electron volts per second, converting to around 3.3 million tons of mass per second. Every second that goes by, 3.3 million tons of additional matter is added. The leap second represents a slowing of Earth's rotational spin, rotational velocity, which is spin. Current mathematical model was derived from present-day work by Stevenson and Morrison, and is based on a solar day equal AV 6,400 seconds. This model wrongly attributes the slowdown to tidal friction and possibly a redistribution of Earth's internal mass, all of which presume a constant mass with some questionable transference of energy and momentum to change orbital motion. Jack Honor, on page 15 of his paper, Deficiencies in Tidal Friction, calculates 5.685 exponent 16 kilograms per year mass increase while conserving angular momentum by using a completely different method. You physicists and mathematicians would be interested in that. This compares favorably to the 9.5 E16 calculation using the lead second and a 7.35 exponent 16 kilogram calculation from the Growing Earth paper.
So I wanted to stop here for a second. Do anybody have any questions about that? So Stephen, you have a question.
Yes, I was just thought it's interesting. The geological evidence indicates that expansion occurs in the Earth's mantle, splitting the continents apart. So this indicates to me that expansion doesn't happen on the continents. So I was just wondering if Gene has can account for that in his mechanism.
The growing occurs wherever these elements are found. Those 8 elements are growing and sometimes heating, and wherever they are in the mantle, the core, or in the crust, they will be growing. So the continents are growing along with the oceans.
Well, I think that's the problem that Steve is pointing out, that if that were the case, then we would have a uniformly expanding Earth, and so the surface would simply get larger. It would not break up like we see in the continental, drift things. We would expect that, if we had a Earth that was like, covered with spots or something like that, that if it were just to expand uniformly, it would be just like blowing up a balloon, and all the spots would get, further apart, but they would maintain their relative position. They wouldn't all like move to one side, which is what we see with the Earth, right?
I don't see it that way. I see the cracks in the ocean are expanding faster than the continents are growing because you have a lot more mass in the mantle that is expressed in the cracks of the oceans and splitting the oceans and making them larger. So it's the cracks. The location of the cracks is expressing more expansion in the oceans than it does in land. For instance, the Grand Canyon is a crack in the land, and there's quite a bit of expansion there, but it's not as great as what we're getting out of the oceans.
So what do you think of that explanation, Stephen? It's that there's so much more mass in the center of the Earth that, causes that cracking.
So you're saying it's related to the volume. So are you saying it's exponential with volume then? You certainly seem to be saying that.
More so, it's the expansion is expressed more because there's more volume in the mantle than there is in the crust. The crust is not expanding as fast. It's still expanding, but not of great magnitude as shown in the oceans.
Actually,
So
we
do you
probably
have
need
any
to support the
figures?
mantle.
Sorry. So do you have any figures of what the difference might be then between the crust and the mantle?
The only figures I can see is that James Maxwell did some calculations, and he got his curve only shows removing the fill that from the oceans, and he comes up with slightly different numbers than mine because he doesn't. I think his theory is based that the continents are fixed and all the expansion is taking place in the oceans. But we can see that there are expansions other than the oceans. If you look at the rainbow map, they show some expansions on the continents.
So I had another question. So you had just presented something about the leap second. And so it seems that your contention is that the reason why they add leap seconds is because the rotation of the Earth is slowing?
That's correct.
Because I'm not 100% sure about that, but I think the reason why they add leap seconds is because the resolution of the second is not sufficient, and that the rotational speed of the Earth is actually constant. But the rotation of the Earth can't not be expressed in exact seconds. So that is why we have the leap second, not because the Earth is slowing. I don't think. Have you heard that?
The Earth is slowing by a half a second a year.
I don't know that that's true or not. And I can confirm or deny that. Does anybody else know about this? Because I don't think that the Earth is slowing by that much.
This is Bill Lucas. We have a number of measurements of the rotation rate of the Earth over time. We have, for instance, the limestone coral. Limestone coral has something that looks like tree rings in it, but there is a ripple for each day. And so you can see how fast the Earth rotated at different times in one orbit of the sun. And it turns out that the highest number of ripples is 485, and currently it's 365. So we see that the Earth has expanded, and when you expand, your rate of rotation slows down, and that's why the day is getting longer, because the Earth is not rotating as fast as it used to. So we have experimental data that shows that the rate of rotation of the Earth is slowing.
All right, but I was looking for some evidence as to what is the actual origin of, say, the leap second. We have leap days, and I don't think that is due to any slowing of the Earth. It's just a catch-up mechanism. All that presuming that the Earth is rotating exactly the same speed. In order to get back to the sunrise at the right time, you have to our limitations of the way we segregate things into hours, days, has to change, and that's why we have like whole leap years, right? Does that mean that lots of years that the Earth slowed down the whole orbit? I don't think so. But in any case, I just wanted to bring that up because I'm not sure that that's correct. Let's go on. We'll kind of talk about the cosmic vacuum radiation.
average temperature of the vacant spaces in the atmosphere. The reason this number is so low is mass is growing at a faster rate than all the heat generated from all the stars and elsewhere, thereby diluting temperature increases. The entropy of the universe is increasing while its temperature is diluting by the increasing space. The red arrows pointing to the last column, percent heating, indicate an extensive heating period between 358 million years ago and 241 million years ago that materially intensified for the 25 million year period between 266 and 241 million years ago. In light of today's global heating debate, where a few degrees rise in temperature in a few decades or centuries is considered highly detrimental to life by many, envision 25 million years of increasing temperatures and its effects upon all life on the planet. Coincidentally, the intensified heating culminated near the Permian-Triassic boundary 250 million years ago, the geological time of the world's greatest extinction. Consequently, geologists should consider excessive heating as a cause for that event. Some recent studies indicate cellular mitochondria produces temperatures of 6 to 10 degrees centigrade above skin temperature. The conventional answer, converting chemical energy from food to ATP, does not address the origin of the heat. Presently, two vital elements for human life, sodium and potassium, are in the heating phase. Is it possible that heat is being extracted from those two elements? I don't have a physical chemistry answer, but it's something to think about when the decay energy of one electron volt is equivalent to producing 11,604.5 Kelvin temperature. Of course, that's over a 1.6 billion year period. Reduced gravity on a smaller planet permits larger life sizes, but does not explain the gigantic dinosaurs of the past. The largest recorded land creature today is a 12-ton elephant killed in 1956. Accordingly, the largest life size permitted with a 50% reduction in gravity, say 175 million years ago, would be a dinosaur weighing 24 tons. How is that possible when the biggest dinosaurs are reported to weigh 70 tons and lived 100 million years ago? Gigantic sizes appear to be possible because we are finding and measuring dinosaur fossils and not considering the minerals that replace the organic dinosaur bone substances. The fossil minerals are from the same matter that produced an 8-fold mass increase in 175 million years. Growing matter allows and limits larger past life sizes, thereby negating the dinosaur paradox. Fossils are rocks, and the rocks are growing. Everything in the observed universe is changing. Subscribing to a theory of everything changes does not negate or denigrate theories based on unchanging matter or theories based on unchanging time, or quantum mechanics, which is consistent with the standard model and relative humidity, special relativity. Changes and adjustments are inevitable when the assumptions are revealed. The merits of each can coexist like mathematical trains running on different gauge tracks. Summarizing, we cover the Ionic growing sun, Earth, and Moon. Known, unknown, known, and consensus. When dark matter exists. The origin of heat, water, hydrocarbons, and life when the element first ionized. Earth's mass was heating for the first 3 to 3.5 billion years. Radiometric dating of rocks over 1,400 billion years ago is false. We showed when the accelerating expansion began on the Earth, Moon, and Sun, demonstrated the Sun's mass increased roughly 4,100-fold in less than 400 million years. When accelerating expansion begins on the Earth, Moon, and Sun, the stars experience punctuated expansion like our Sun that began less than 500 million years ago. The expansion mechanism, the energy converting to mass, per Einstein, density is unchanging except for compression. The leap second quantifies the atom mass. CVR is the average temperature of the vacant space in the uniform. Global warming likely caused the mother of all extinctions, debunked the dinosaur paradox, and indicated a possible mitochondria heat source. Thank you. Okay.
Okay, so that's, oops. So that's Gene's presentation. So I'll open the floor up to questions for Gene. Let's see here. Do you have any questions for Gene? From the floor. Okay, Mitch.
Thanks, Franklin. Gene, I'm just kind of wondering if you subscribe to the to that theory where gravity is caused by everything expanding.
So Gene, you'll have to unmute yourself. Yeah. Or I'll unmute you. Go ahead. So, Gene, have you even heard of this theory that gravity is caused by an Earth expansion? Are you there, Gene? He might be having some problems. But I mean, are you talking about the theory that the Earth's surface is expanding by 9.8 meters per second? I actually call that the exploding Earth theory because it would have to be expanding that rapidly versus the very, very slow expansion that I think.
Okay. Yeah, you're probably right.
Because those are two different theories. One is that gravity is caused by, I was trying to explain that last week that, the Earth's surface is expanding extremely rapidly, pushing everything out such that inertia keeps us down. But this kind of expansion is like, maybe increased like 4 times over the course of like a 3 billion years kind of thing. So it's very much slower than that.
Oh, okay.
But I was wondering, as a dissident scientist to another, what do you generally think about Gene's theory? Is this something that you could believe in and get behind, or are we just all nodding politely and say, that's nice, Gene, but we don't believe a thing that you said? So how do you feel about that?
Well, I'm sorry. I think somebody else might be talking.
My question is, does Gene's theory conserve energy?
What would be the relevance of that? I don't think he talked anything about energy conservation.
I know, but he has energy growing over time, and it seems like it's a theory that doesn't conserve energy. Quantum mechanics and the Big Bang doesn't conserve energy either, and but that's a question that might be of interest to people who are more classically based.
So what about a Gene? Is energy in the universe?
Energy is conserved because the energy is being converted to additional mass or to heat.
But mass and heat are energy.
Pardon?
Mass and heat are energy.
They have equivalency in energy. The energy is decaying, and as it gets older, and that energy is converting to either mass or to heat. And if you want to call heat energy, it's converting to heat energy. That's what the physicists want to say. If you look at matter being defined as energetic elemental masses, then the energy can convert to mass.
Although, there's no actual mechanism for how that happens. I keep on explaining to people that if they're going to keep on asserting that mass converts into energy and energy converts into mass, that you can't say that without having any causal mechanism for how that happens. Otherwise, it's just a complete bit of magic.
Well, does Einstein have any causal mechanism for E equals mc squared?
Well, I certainly do. I mean, I keep on explaining to people this recently as, the day before yesterday, that what's going on with E equals mc squared is that, specifically in, say, pair production, that when you send in gamma rays into empty space, what that's doing is that is the binding energy of a positron-electron pair, which is already there. And what's happening is that E equals mc squared, that's very similar to the kinetic energy formula, which is 1/2 mv squared, exactly the same format. And that when you have a positron-electron coming at each other, and they're very highly attracted, so the positron will be coming in at 1/2 mv squared, and it will eventually reach the speed of light as its maximum speed. So the kinetic energy is 1/2 mc squared. The electron coming into a positron-electron annihilation is also going to have 1/2 mc squared. So you add those two things together, and the total energy of the impact is, in fact, mc squared. So that's where, that's my explanation. There are alternate explanations.
Well, another explanation is in the micro world, you just let C, speed of light, equal 1. And you have energy converting to mass.
And how does that happen?
Ask Einstein.
Energy is like me waving my hand. Energy is basically matter in motion. Okay?
I think it's generally accepted that
that makes sure it's generally accepted, but you're generally accepting something which you cannot explain at all. See, that's kind of a problem.
The law
no explanation.
The laws of energy mass is that neither can be. Yeah, neither can be. I got
Well, there's the law of conservation and every other chemical reaction.
Right. But Einstein came along and they changed the interchangeability part of it. So that's a corollary to the law, and it's acceptable. I think everyone realizes that energy converts to mass.
Except for me. So as a dissident, I have alternate explanations which make a lot more sense, which do not require magical creation of mass. I mean, basically, if a magician pulls a rabbit out of a hat, is it logical for you to think that the rabbit just materialized in the hat? Or is it more logical to think that the rabbit was actually in the hat and the magician just pulled it out? Now, if you're saying that energy converts into mass, then you're saying that, yes, the rabbit just materialized out of the hat, and that's what the magician pulled out. I'm saying that that's nonsense. I'm saying that whenever we see this bit about like energy being converted to mass or mass converted into energy, what we're actually seeing is that when energy is being converted into mass, is that we're seeing actually particles being broken apart. The energy is being used to break those particles apart. And then when we see mass coming back into energy, what all we're observing is the release of the energy due to the impact. So when I clap my hands, none of my hand disappeared in that, but you heard the sound that was produced at the impact. And that is the so-called conversion of energy to mass that we're seeing when we see E equals mc squared. So I'm just saying there are alternatives. There are definitely alternatives that do not require a magical conversion of energy to mass. And that mass, say in my opinion, is always conserved and energy is always conserved and they're never converted. But once again, that's my opinion. But Harry has raised his flag, so let's get to Harry.
Oh, okay. Well, I have a trivial question for Gene. Gene, you mentioned that you're an engineer, but you didn't say whether you're a mechanical engineer or a civil engineer or what.
Mechanical.
Okay. All right. Now I have a question for Bill Lucas, if I might ask it, but if nobody else has any more questions for Gene.
Well, Cornelius has a question, so why don't we get to Cornelius, and if no one else has a question, you can bring it up again.
I've got a question for Gene, if I can.
Go ahead, Stephen.
Is that okay? Hi, Gene. It's Stephen Hurrell again. I'm still confused as to whether you think expansion occurred in the continents. Because in your talk, of course, you've said that the continents expanded sufficiently to explain the large size of dinosaurs, because, of course, fossils have, I think you said 8 times the mass, but that would be twice the linear size, which would explain the large size of dinosaurs. But just before, you seemed to be saying that you didn't think there was that amount of expansion in the continents when you answered the question. So I was just wondering, could you clarify, do you think it's expanded that much or not then?
Hold on a second. I'm saying that the elements, wherever they are, and they are in the all over the ground, they're underground, they're in the mantle, and they're in the core. So wherever the elements are, they expand at their own rate. Each element is expanding at a different rate when they are growing. And those numbers are in the moon, sun, and Earth papers in Table 2. So on Earth, oxygen is doubling its mass every 23.7 million years. Iron is doubling its mass every 82.98 million years. And magnesium is doubling every 36 million years. And calcium is doubling every 59 million years. They're all doubling their rates at doubling their mass at different rates.
Oh.
So what table 4 does is it takes the percentages and compensates for the percentages and compensates for the atomic mass units of each element, and that's how we come up with the 1.6 rate of decay on Earth. And on the moon, with different elements and different percentages, we ended up with 2 point something every 2 million years, 1 electron volt every 2 million years. And then on the sun, it ends up around 1 electron volt every 8 million years. So when you use those numbers and have a decay rate in different places, if you took Mars and you could give me the elements and the percentages for the total planet, not just the crust or the mantle, but the entire planet, you can figure out what the decay rate is on Mars or Jupiter or any other planet or any other moon. It correlates everything back to the ionization potentials of Charlotte Moore's MBS 34 publication. And if those numbers change some, then those adjustments can be made.
So you're saying that we know that fossils are replaced by different minerals. You mentioned iron and calcium. So you're actually saying that fossils will be different sizes depending on what they've actually been fossilized by.
That's correct. They found fossils in French gypsum quarries, and that's calcium sulfate. That's two of the elements. They found them in Belgian coal mines. They found fossil remains that turned to pyrite when exposed to moisture. Well, pyrite is iron sulfide, and iron sulfide is also known as fool's gold. So if you find a piece of fool's gold, you might have found a piece of a dinosaur. They found it in fossils in Colorado and Wyoming, and these are silicified bones, silicon. They've also found them in magnesium-rich areas in Calgary. So they're all the 8 elements. The 8 elements make up 98.8% of the Earth. You're bound to find them there.
Okay, but you were saying they have a different rate of expansion, so that would imply that different fossils would be different in size, and yet that isn't what we see. If we look at just a well-known fossil of T-Rex, it's fossiled in. We have black fossils of it and white fossils of it, depending on different materials that have fossilized it. So there should be we should be seeing a difference in size, but we're not.
Of the same age?
Of the same age, yes. Well, T-Rex, obviously, they're all around about 67 million years old. So we can compare old fossils, and from what you were saying, you know, there should be a different size, but as far as we can tell, they're all around about the same size.
Well, they're all oversized, because if you compare it with the largest size animal we find on the earth today, which is a 12-ton elephant, if you find something larger than that, then that will become the largest size. But a 12-ton elephant at 50% gravity, the maximum it could weigh is 24 tons. And they're having these bones or samples that they're taking, and all indications are all over 24 tons, which means something is growing.
Yeah, 24 tons isn't the correct figure. It's around about 80 tons. I mean, it was half today's gravity. It'd be around about 80 tons we're talking about.
No, half of today's gravity would be twice.
Well, he's just trying to tell you that there's some alternate information here. I mean,
okay. Well, I don't see 80 tons as.
I mean, it could be 80 tons. You know, we tried to bring up some contradictions to what you presented here, so that is perhaps one of them. I'll also mention the origin of the leap second. That might be another one. And but I was just wondering, Gene, from a philosophical standpoint, I mean, would you welcome your theory being perhaps proven wrong? For example, if space aliens with a super advanced knowledge of physics were to appear on the Earth, and you explained to them your theory, and they told you that you are completely wrong, would you welcome that, or would you just deny it? How would you react to something like that? Because it's something I kind of interested in the dissident world, that I think that some people will hold on to the theories no matter what. But what is your philosophy on that?
My philosophy is there are no alien coming in. You would have.
That's just philosophically saying, would you welcome that, or would you just would say that you aliens, you're wrong, you don't exist, therefore I can't be wrong?
I think he beat you on that one, Franklin. Let's move on.
I'm not saying I can't be wrong. I'm saying that I don't see any alien. I don't see any life form.
Well, let's suppose God comes. If you believe in God, suppose God, Jesus Christ.
Let's move on, Franklin.
I don't think we ought to bring religion or politics into the issue if you're dealing with science. If you want to deal with those things, they impinge on it, but I don't think they should be considered along with it. So if you believe
you have some comments here. I want to ask you, Harry. So you've been hearing Gene's theory saying that there's ionization, that this ionization has something to do with heating, and that this causes the elements to expand, and that the Earth has been expanding.
The elements are growing.
Growing, you know, over the past, actually fairly recent, like 100 million years or so. Now, frankly, I don't believe any of that. So, Gene, just to let you know, I mean, it's okay for people to disagree, and I'm just letting you know that I find none of that convincing. But I was just wondering, so Harry, what do you think? Are you convinced, or are you just going to nod politely, or what is your opinion here?
You're asking me my opinion. Okay, my opinion is that I don't understand how dinosaurs can be as big as they are. And I don't understand how these creatures that they're finding, the bones of, they're gigantic and they're huge. So I think that's the best argument for something is going on. Either gravity is changing or something is different. So I don't, you know, then the cracks in the ocean floor are certainly the argument that mainstream puts forward doesn't really make sense, that somehow another additional matter is welling up from the ocean floor, but it's disappearing someplace else. That's kind of hokey pokey and seems like magic to me, if we want to use that word.
But what do you think? Because a lot of that is common with the Earth expansionist, theories, and certainly Gene is not trying to,
I think what Gene has done is he's sort of given some an argument that says, okay, this is how we can calculate the this process of change that's going on based on his theory that he has, that the ionization data demonstrates it. And my question to Bill is, Bill, do you think the new data changes his conclusions much at all, if any?
Go ahead, Bill. There, you have to unmute yourself.
He may not be here.
No, he's here.
Oh, here. Okay. Well, I have a number of comments. One is the reason that dinosaurs were able to live and they were so much bigger than the animals today is when the Earth was smaller. It's been expanding over time. When it was smaller, the density of oxygen was higher on the surface of the Earth, and that is what these animals need. And the reason why they died out is they couldn't get enough energy to move their bodies and everything, because as the Earth expanded, the atmosphere was spread over a larger surface, and there wasn't as much oxygen available to them, and so they couldn't get enough oxygen to keep moving their bodies.
Let me ask this, Bill, just to interrupt you. Does mainstream have an explanation for this dinosaurs being so huge? Do they actually have a theory or an explanation, or is it just something that they avoid dealing with?
I'm not a biologist, so I'm not an expert in that field, but I would say they don't attempt to explain it. They just say that the animals died out due to some other process, which could be a genetic process, it could be a loss of food supply or whatever, that they needed. And so,
yeah, but these animals are huge, and you'd think that, this would, be an issue that would be a subject of controversy as to how to explain it.
I think they may have had some. I mean, probably if you go look on YouTube, you can probably find it a lot. My understanding is that it is a genuine still mystery as to how they could possibly get that big, because if they were, by known physics, they would not be able to be viable under current conditions. I think that, but once again, I'm kind of just knocking them out there. But well, I thought that was still a genuine concern. But we are getting towards the end of the talk here. So, but I was still trying to just find out from other people who have been listening to the conference whether they agree or disagree. I mean, Gene, what are you hoping to find from this conference and the comments? And I've been trying to give you some critical comments, and I don't understand things about how you're interpreting the ionization chart. I mean, you seem to be almost interpreting it backwards. The ionization chart does not have anything to do with anything which occurs over time. So I don't see any logical connection between the ionization chart and the 1.6 million years, or why that would even imply that these elements would be growing in size. And there's just a complete disconnect for me on just that basis. So,
well, there's other truth coming up. They're changing the definition of the kilogram probably next month or a month after, and keying it into Planck's constant. And why are they doing that? they're doing that because the grand K, the mother of all kilograms that is kept in France, is gaining weight, and they don't know why. And the whole concept is we're looking for something that is unchanging. And in a universe where everything is changing, if you don't have something that is not changing, then you have nothing to measure it against.
Well, I would say that I don't disagree with that, but for example, that change might be due to this pair production thing. You know, we've mentioned that before. I mean, when we consider theories like this, first of all, you have to accept the whole idea that the Earth is expanding, and that in itself is not accepted by mainstream. But assuming that you do, then you have to be able to separate out the various alternatives. You know, one of them is that we have this pair production going on in the core of the planet, and you know that would happen on your kilogram, and so there are alternate explanations. But why should we accept your explanation? So, and your explanation has to go specifically to this concept of ionization, which, like I said, you know, that's why I stopped at that chart and
it's taking the data.
What that logic would be there, but
it's using the data of ionization to come up with it.
What you're using to come up with is kind of this historical chart of what you think might have happened in the past. But what I don't see any evidence of is that that's actually what happened in the past. So it's like I could use instead of using the ionization chart, I could use the chart of the last 16 lottery winnings and then use that to project what I thought happened to the Earth in the past. And you would think, well, that's complete nonsense. But that appears to be what you've done here, is that you've taken some arbitrary bit of data, which is ionization data, and then map that back to a history that we can't confirm, right? You can see that's kind of a problem.
Well, if you follow the examples I gave in the Ionic growing Earth, it tells you how I came up with it. If you find something wrong there, I don't mind you telling me.
No, the thing is that you're trying to predict something that's happened in the past, which is great. Like you can predict, you know, the Earth was like half its size, you know, 150 million years ago. But we have no confirmation of that actually happening, right? This is a big problem, that we don't have no actual confirmation. Now, well, maybe, mentions like the rings, and maybe you could confirm the actual size. But because no one was back there that time to confirm, it's like you're predicting something that you can't confirm. And it doesn't matter how good your calculations are. I mean, your calculations be 100%, but they could still be not relevant to what actually happened in the world. I mean, why should anyone believe your figures, right? What evidence do we have that can be collaborative, that can collaborate what you're saying? And I don't mean to be mean here, because I'm saying that you know, this is the problem, that nobody in the mainstream is going to accept it for this particular reason, right?
It's not accepted. It's not accepted mostly in physics because atoms can't grow. They can't change size, and that is an assumption. And if you don't question the assumption, or the reverse of it, saying that they do grow, they can grow, that's just as valid as saying that they can't grow. And if you want to accept
that would be your burden of proof.
If you want to accept that atoms don't grow, then you're saying that the radius of the Earth is constant. It hasn't changed since the beginning.
No, that's not true. You know, the alternate explanation that the digital mass is due to, say, air production, or maybe it's due...
You're saying we're importing the mass from somewhere else in the universe. So that means that any mass that you're imported somebody is exporting, and the universe is staying the same size because whatever you're importing, someplace else is exporting.
Yeah, but maybe that's okay. Maybe if it's just all the meteorites hitting the Earth and making the Earth bigger because, well, it's just accumulating more stuff. I mean,
well, the numbers show.
The solar vacuum cleaner would work perfectly fine.
The numbers don't show exponent 16 kilogram mass per year. And that number I got 6 different people with saying that the Earth expansion, the amount is in the range of 6.5 to 9 point whatever exponent 16th power kilograms per year.
Now that was based on your whole leap second thing, wasn't it?
No, that's I got 6 people, 6 different. Let me see if I can find it. 6 different.
Because I've never really heard of that estimate. I know that they have estimates of the amount of the net change in the Earth's mass due to meteorites and solar debris, and it's quite substantial. That I don't know that it's enough to significantly change the radius of the Earth over time. They know that they do exist.
We got Giancarlo Scalaria. He indicated in 2003 an increase of 1.37 exponent 16 kilograms per year. Max Low in 2003 indicated 6.0 exponent 16 kilograms per year. And Chemowitz and Cozier estimated 2.8 exponent 16 in 1994. Then I have Jack Horner with 5.6 exponent 16. I got the leap second data, and my own data is 7.35 exponent 16 kilograms per year. You're talking about adding 3.3 million tons of new matter every second. That's what that represents. Now, you showed me where comets and all them other things can accumulate that much, 3.3 million tons per second, then I'll start believing your stuff.
Well, they're all alternative. I mean, you can never tell. If the pair production thing works, then yeah, you could produce 3.3 million tons a second easy.
Well, pair production, where's it getting this? From other planets?
You mentioned at the beginning of the discussion here, the core mantle of the Earth is as hot as the sun. So that's super hot. Energy on almost unimaginable scale at the center of the Earth. So if you're looking for an energy source, I'd say, yeah, that's a perfectly viable energy source right there. It's almost as if the Earth had a sun inside of it. That much energy.
Yeah. Has anyone come up with?
I mean, it's actually quite a mystery as to how on Earth, relatively cool here on the surface, but in the core, it's an
interesting theory from the heat standpoint. But if you're claiming that's where the Earth is getting its heat from, then I would be questioning that. Let me give you a speed of light thought experiment. Imagine looking at a twin sister of our sun, an exact duplicate that is located 100 million light years away. Will we see an equally sized twin, or would we see that sister star as our sun existed 100 million years ago? If the universe were not expanding, the twins would be the same size. If the universe is expanding, then everything within would be getting larger, and we would see a younger, smaller star at that distance. The Ionic glowing sun indicates that size is around 30% of the sun's present radius and about 10% of its present mass. As usual, the cosmologists and the physicists claim that the 90% missing gravitational mass is due to dark matter. Well, all the elements have ionized, and therefore the only way it can revert back to dark matter is when the energy, the intrinsic energy of the elements is exhausted. Then it could become dark matter again, but I don't think we're at that point. We're in the...
I kind of really have to question what your idea of ionization is. I mean, do you know what they mean by ionization? Do you know what they measured in that chart? Tell me, what does that mean?
They're measuring when an element has the potential to join other elements.
No, they're not. That's totally not what the ionization chart says. If that were true, that chart would have been labeled.
That's the chemistry.
It would have been labeled the energy at which an atom can form chemistry. That's not what that chart is.
Well, I disagree.
Do you know what you do? You should just look in Wikipedia, look under ionization, and find out how that experiment is actually done.
You have many definitions for ionization as you do for...
No, there's a single definition for ionization, and that is the amount of energy required to eject an electron from a ground state atom. So if you have a helium atom, it's got 2 electrons. Now, it doesn't matter whether you think they are orbiting or not, but the amount of energy listed on that chart, the first one is the amount of energy that has to be injected into that atom in order to remove 1 electron from that helium atom. And then the second number you see is the amount of energy. It takes more because it's got 1 electron around 2 protons. So it takes more energy to eject the second electron from the helium atom. This is what ionization is. Okay, and that's what those numbers are. I mean, I know that for a fact. That is settled science.
You're hung up on your own on that definition, and there are other definitions of it too.
No, there are not other definitions. I'm telling you, there are not other definitions. You presented that chart, which is, I accept that chart. I know where that chart comes from. I'm familiar with those values. And
you don't think it says anything?
Would say that they would have to agree that that is what that chart is saying. I'm just saying that you're misinterpreting that chart somehow, that you don't understand what ionization actually is.
Well, maybe you're not including everything that's represented on that chart.
No, I know. It's a very simple experiment. It's nothing to it. That chart represents the amount of energy required to eject an electron from an atom. See, so it doesn't have actually anything to do with chemistry on the atom. It's related, but it doesn't have anything to do with at what point is an atom capable of forming chemical bonds. Because, you see that for an atom like, oxygen, it's got like 16 possible ionization energies on it, which correspond, well, actually 8. The 8 electrons like that is possible to be ejected off of oxygen. Now, oxygen only produces 2 chemicals with 2 bonds. I mean, if ionization had anything to do with that, why not 8? Why not have an ability at every single ionization level? And it isn't, because it's not related. I'm just trying to be helpful for you here, Gene, because I think you might be I mean, if you're at all interested in the truth about, you really believe that this is really, really happening, but you need to look into these issues, right? Now, you don't have to believe me, but you should look into what I'm talking about and understand what is involved here and why I'm objecting to what you're saying, right? So I would hope that when you come and you talk to people, that that's what I look for. When I talk to people, I want them to tell me where I'm wrong, because the most boringest thing for me is if I go to a group like this and everyone just nods politely, and that's completely useless, right? My theories cannot go forward without being challenged. So I would answer my own question is that if the aliens came, yes, I would totally welcome. I would totally want to know what the truth is. And if my theory is wrong, then yes, I would totally want to know that. Right?
Well, no one has told
what I'm trying to do here is that I'm trying to encourage people. I think people in these types of forums are generally too polite. That they won't call you on the things that they're really disagreeing with in the back of their mind, and I don't think that helps you, right? You need to be told things like your concept of ionization is not correct, or your concept of leap second is not correct, or that we have these situations where we can find different fossilizations of T-Rexes and they're all the same size. Those are things that you can go back and you can take a look and you can research those things and find out, well, yeah, there's a point, or maybe there is no point, or it's something that you can later argue or change or something like that. But what do you think of that, Gene? Is this helpful or not helpful? I don't know.
I think I'll stay with what I have.
Okay, well, I think a lot of dissidents do that, which is that they will doggedly stick with what they have, but you got to wonder, why your theory goes nowhere and why nobody believes you.
Oh,
as a dissident myself, we're trying to seek the true truths of what science, and believe eventually there will only be one truth, right? Can't all be right. Fact is, we're probably all wrong. But if we just simply continue to agree to disagree, and if we continue to just say, I'm going to stick with what I've got, and I'm not going to pay attention or look up anything else, look at the reasons why people aren't accepting my theory, then
I'm seeing more and more evidence that the elements are growing. I see it happening maybe in 20 years when they reweigh the Grand K and find out how much it is growing, then maybe they'll start thinking that these elements.
Well, you see, I don't have any problem with that concept. I mean, I don't have any concept that perhaps the Earth is increasing. I see evidence of that, and even that the Grand K is increasing. But I don't see any relation between that and the ionization chart. That's my problem there. See, all those other things can happen that don't have to happen due to what you think the causal mechanism is. Just saying.
I think the mechanism is Einstein's energy converting to mass, as far as the expansion of the universe is concerned. But it doesn't answer where the heat is coming from.
And it doesn't answer how it actually happens.
Huh?
It doesn't answer how it actually happens.
You can't say
Well,
it.
in any case, we are actually over time, so we are going to have to end this discussion. But Gene, thank you for coming very much and presenting your idea of the idea that the atoms themselves are increasing, and that it is intimately linked with the ionization chart.
I'd rather say that the elements are increasing, and the elements have atoms, and the atoms of the elements are essentially the element. One atom of iron is still iron.
Yeah, and it's just somehow getting bigger, right? That's
No, the atoms, yes. Yeah, the atoms are getting bigger, the elements are getting bigger.
yeah, the elements are getting bigger. So that's one way it could happen. So if you're interested in that idea, I do have the entire video on the invitation invite. You can go back and review that. This video will also later be posted on YouTube, so you can also review that as well. But I would take to heart any comments that you've received here today, because as a dissident organization, we enjoy and encourage you to have alternate ideas and to come here and have those ideas challenged. Okay, we're not just going to sit around. We're not going to say that your ideas are crazy because you're not part of the mainstream. We don't do that, but we will say that your ideas are crazy because they violate certain principles of physics, and that's perfectly fine. So that's what we're here for. Thank you, Gene, for presenting your ideas, and if anybody else has any ideas they would like to present and be challenged, once again, I invite you to contact me at franklinhu@yahoo.com, and we'll be happy to put you on. Any ideas fair game here on the CNPS. All right, so that will do it for this week's episode. I don't have anything planned specifically for next week, so like I said, I invite you to send me an email. But that will do it for this week's chat.